let's look at a rational function that exhibits some non-removable discontinuity so we can see how to find that and talk about that and see what makes it non-removable versus a removable discontinuity that we've talked about in a previous example. So again, I'm going to start off by factoring everything that I can here. My numerator is already factored. It's just x plus 1. There's nothing I can do there. In the denominator, I see a difference of squares. X squared minus 4 is a difference of two perfect squares. So that can factor as x plus 2 and x minus 2 with that. Again, feel free to review any videos on factoring difference of squares. If you're like, where in the world did that come from? That's something that we've covered previously in the course with that. So here we have the factored form of our function. I can look at this and I can see what values would make the denominator equal to 0, where the function would be undefined. Those are my points of discontinuity. So this would be discontinuous at x equals -2 and at x equals +2. Those are the two values that would make the denominator equal to 0. And then we look at the numerator as well, and we want to see if we see any of these factors from our denominator also represented in the numerator. In this case, I do not. So this factor of x plus 2 is not going to get canceled out and removed from the problem. This factor of x minus 2 is not going to get canceled out and removed from the problem. So because that does not happen, that factor does not exist in the numerator to cancel itself completely out of the denominator, we have what we call non-removable discontinuities. So both of these discontinuities are non-removable, and again, they are non-removable discontinuities because there was not enough factors of that in the numerator to be able to cancel it out completely from the denominator. This is as simplified as this function can get, and this factor of x plus 2 still exists in the denominator. Therefore, the x value of -2 is a point where this is discontinuous, and because that factor is still existing in the denominator in the simplified form, it is a non-removable discontinuity. Same thing here. This factor of x minus 2 is still existing in the denominator. The value that would make that equal to 0 is +2. Since that factor is still existing in the denominator, it did not get canceled out completely, we have a non-removable discontinuity there as well. So this function has 2 points of discontinuity at x equals -2 and x equals +2, and they are both non-removable discontinuities. So what does that mean for the graph of the function if these are non-removable discontinuities? Well, a non-removable discontinuity here is represented by a vertical asymptote when we looked at the graph. So this graph would have vertical asymptotes of x equals -2 and x equals +2. So if I look at the graph of this function, I should see those vertical asymptote lines at -2 and +2 here. We call this non-removable because if you look at how the graph behaves at a vertical asymptote, how it just approaches it from one side or the other, you can't redefine something to just fill that in. It's not like there's just a little spot, there's a little hole in the graph where I can just be like, oh, let me redefine a new point there and then have the graph be continuous. If I have an asymptote line like this, and the graph is doing something like this over here, and something like this over here, I can't just fill in something in between here that would make this continuous, since this one end is going up forever, and this end is going down forever. Whereas if I just had a hole in the graph, so like I had something like this, I could be like, let me just put a point there, and then the graph would suddenly become continuous. That's why we call that one removable and this one non-removable. I can't just redefine a point and fill in the problem. It's like I can fill in a pothole, like I referenced in another example, but I can't fill in the Grand Canyon if I had to liken an asymptote to something that would be impossible for me to fill in. I don't know, I'm just making stuff up now.